Good morning, all, and welcome to the another session of Structural Analysis 1. I hope all of you can see the screen and just tell me whether it is moving or not in the chat box with yes. Right. So just respond in the chat box. All right. Okay, thank you all for responding. So welcome and let's start. I hope all of you have collected your writing tools with you as and when required. We can do some book work or some calculations are needed, then you can carry on. And please enter your details in the chat box for your attendance as usual. And we'll be beginning within 1.5 minutes. Let everybody join the session. I can see most of you are there, but still will wait for 1.5 minutes. Meanwhile, I think yesterday I have shared yesterday or day before, I have shared one handout with you, lecture notes with you, with some corrections, which were I found I was calculating some other numerical, but I spot the error in that. So I corrected it and found the error, and that's why I shared with you again. So I hope it's received by all of you, and now it is perfect and you can refer it for the further calculation and learning. And today, as decided, we'll be going for another method, as you can probably read from the slide itself. One of the most exciting methods of truss analysis, that is called method of section. Very interesting and very customary also, like you can customize the calculation of the members within no time. Directly you can focus on a particular member forces out of the large numbers of members. So let's start this exciting journey and let's carry on. So as you can read the question, when should the method of dissection be used? Right. So the answer is very simple, like in case when only selected members are to be analyzed for the internal forces from the given system. And when the truss consists many number of forces or many number of members, and method of joint seems time consuming. As you know, in the method of joints, we used to go to the each and every joint and we divided the inclined members in sine and cos components, and then we applied the methods of, the conditions of equilibrium like sigma v and sigma h. Though the method is, there is a benefit of a method of joint is it is simple in nature in application, but it consumes a lot of time. So you will realize that when you have number of members in a truss system, like here it is, there are some couple of examples I have selected to share with you. When you have a complex structural system in terms of trusses, here you can see a couple of examples, like one is a bridge example, second is the industrial truss example, and second is also the similar type of industrial or roofing truss. But the only limitation of this trusses are they have many members, right? And you can imagine that if you can solve this, no problem, because these are the determinate trusses only, externally determinated, and you can definitely calculate reactions, and then you start attending one by one joints and you can solve them. So it's not a tough task actually, but it's a long task. So time is large, and more time is needed, and it also requires a lot of care in terms of compression and tension members and all. So once you determine the forces in a particular member, you need to remember that which was actually compression and which was actually tension, and accordingly you have to reapply the same forces to the new joint, right? So this problem is eliminated in terms of method of section. So suppose, for example, on a right hand, on a left hand side, you can see this blue truss, right, which is applied with many of the forces, and there are many members. Now if I ask you that please find the force in member BG within 5 minutes or 10 minutes, it will be very difficult for every one of us, because typically we will start first of all calculating the reactions at the supports, then we start solving joint C or joint A, then we'll go to joint B, then we'll come to joint E, then either we can go for joint B or joint G, and then finally probably we may be able to calculate member force in member BG. That is the diagonal here. So 1, 2, 3, 4, 5, and probably 6 joints are to be analyzed, first of all, to reach to the desired member force. Now, in this method of section, these conditions are eliminated. How to do it, what to do it, that I'm going to share with you. And for a better comparison, and convenience, I have selected the same problem that we have resolved earlier by method of joints. So by comparing method of joints with method of section, you will come to know that it's quite easy, not easy maybe, but quite faster, right? So let us enjoy this method, and then we'll carry on with some little more complex problem. I think I have shared earlier one more problem for a practice to you, and those who have solved that, they can compare the answers in the next exercise. Right. So let's have a quick look on what are the primary steps for the analysis of a plane truss by method of section. So determine the truss, whether it is perfect or not. Draw the free body diagram by releasing the supports and replacing it with reactions. Calculate the reactions, select the location for a section. So from step 4, your method changes. Now in this method of section, you have to take section. That means it's a line, it's an imaginary line through which you need to actually cut or separate the entire truss in 2 components, where you take a section. Just similar to earlier what we used to do in case of calculation of bending moment in internal locations of the determinate beams. We used to separate beam by a section, and we used to consider left hand side and right hand side. So same methodology we are going to apply for truss also by selecting appropriate section. But there are certain rules and regulations for selecting the section that I will be discussing with all of you, such that you will be able to use it. Then once you select the section, separate the truss at the section location, convert the forces, convert the members into the forces. So once you take a section and cut the members, those members which are being cut, they will be represented as forces. And all these forces are assumed to be acting in a tension as usual, right? And then apply the equilibrium conditions on either side of the truss cut sections. Let us say when you have a truss, and when you cut it at any section, it will get divided in 2 parts. So there will be, of course, left hand side and right hand side. You can select either of them and apply all the equilibrium conditions one by one, and try to see that whether you are being able to solve the unknown forces or not. Right. So that is all about the methodology. Now let me bring you to the numerical. So this is very old numerical, very familiar numerical. Earlier we have solved this by method of joints. Now let's see how to use method of section on a same. So without going into the detail, let's do the initial job, that is calculation of the perfectness of the truss. Earlier we have done this, so we know that it is perfect truss. Then similarly we'll be determining the support reactions. We have replaced supports by the symbols, and this is how we obtain the reactions. So till here there is no doubt, there is no problem at all. Everybody knows that how to do it, and this is a very similar step that we have already adopted. All right. So there's nothing to tell you in detail. This is VA, that is 35 kilonewton. VD is 15 kilonewton, and the horizontal reaction is 20 kilonewton. Right. All are positive. So again, we have identified that these are the zero force members. So force in AB and BC will be zero. So now let's check how your world gets changed when you are starting with the method of section. So now let's apply the method of section. Suppose we want to calculate directly the member forces in AC member and CE member. So here you can see AC is here, right? This is inclined diagonal member AC, and another member is CE, or you can call it EC also. So these two members are to be determined for their internal forces directly. So earlier, what we used to do is we used to come to the joints one by one. We started, if you recall, we started with joint D, and eventually we came to joint B and finally at joint C. So it took a lot of time also, as well as it was tedious job also, right? Because you have to go at every joint and node. So let's see how to apply the sections method of sections. We are interested to find forces in AC and CE member. So assume the suitable section such that there are some rules which I was discussing, that maximum 3 numbers are getting cut in a one section line. This is a very prime and foremost condition for selecting a section line. Section is nothing but a line, right? A dotted line that we can use to cut the truss. But when you are cutting the truss, take care that not more than 3 members are being cut at a time in a one single section. Why this constraint is there? Because we have only 3 conditions of equilibrium. So that is the reason, and that is the limitation why we should select a section such that only 3 members are being cut at a time at a section. And second is the member of which the force is needed is already in the section. Suppose, this is again very important, because when you take a section, you have to take a logical step such that not more than 3 members are being cut, and out of those 3 members, at least that member in which we are interested should be a part of that section. So I hope you are clear. Let me tell you, for example, we are interested first of all in calculating member force in member AC here, right? So naturally, if I take section horizontally, let me demonstrate it. If I take a section like this, it won't work. It is not correct. Why? Because it is not satisfying first condition. You will see that this line is cutting 1, 2, 3, 4 members together, which is not allowed. Right. So what are other options? You can select section like this. Right. So that cuts 3 members together, 1, 2, and 3. Another option is straightforward, like this is what I have selected for this analysis. You can use this vertical cut that will separate the truss in left hand side and right hand side, right? And you can see that it is only cutting 3 members, member BC, member AC, and member AE. And second condition, we have satisfied that member AC is a part of this section, right? It is included in this section. It is being cut in this section. It has to get cut. That is the condition. Okay. So this limitation you have to remember always. These 2 things you have to always remember while you are taking a section. However, you can take a section like this also, not an issue, because the number of members which are being cut is less than 3. So that is fine. But at the same time, this section, like this line, should never be practiced because it is cutting more than 3 members, right? So please note that there can be as many sections as required. You can take one section here, second section here, third section like this, whatever number of sections you want to take, you can take on a same truss, right? There is no rule for maximum number of sections. For example, we need forces in AC and C members in the present case. Therefore, we will take two sections to divide the truss. Use only one section at a time, and according to that, divide the truss into two segments. So another point to be remembered is, at a time you will entertain only one section. Suppose, let me remove all this and okay. Now suppose right now I have considered, since I'm interested in this, let us say CE member. So I will take this section, for example. Now I will do all my calculations and I will obtain the answer of CE. Now I want answer of AC. So at that time, I will forget this line and I will cut the member like this. I will forget about this, and my new section will be left hand side and right hand side with this option. Okay. So that you have to remember, that once you have used one section, forget about everything when you start with a new section. Because for every individual member, you are free to use whatever type of sections you want. But once you have used it, then everything will start as a new when you use new section. Okay. So these 3 points are very important. I'm sorry. I'm in little cold, so nothing to worry. Okay. So where I was, yes, I was saying that these 3 points are to be remembered always when you are taking a section. So I hope how to take section is much more clear, and it will become crystal clear once we start with this solution. So let me bring you to the solution by removing these unnecessary lines and going back to the arrow. Okay. So friends, let's start. This is what the exact page we are interested in. Let us now apply method of section. Let us first find the force in member AC. You will see that I have selected section 1.1 in such a way that I am cutting the truss in a way that it will divide this truss. This section will divide the truss in left hand side and right hand side, such that member AC is being cut, and also it is not cutting members more than 3. So this is one member, this is second member, this is third member. Member BC, member AC, and member AE, all are being cut together by this section 1.1, such a way that it divides the truss in 2 components. And also AC member is a part of this section. So observe the truss and select the section 1.1 such that the member AC getting cut along with the other maximum 3 members as shown in the figure below. So I hope we all are clear till this point. No confusion, no issues. Right? It is very simple. Okay, let's go ahead. So now you will see that on the right hand side, I have divided the truss in 2 components. Now please take a close look. Maximum, the learning part is on this slide only. So please learn it carefully. You will be seeing that when I cut this truss by section 1.1, my all 3 members are being cut. So these members which I have cut, I have represented in form of forces, tensile forces, right? So always remember that when you cut a section and when you cut a member, that member will no more remain as a member, but it will be shown as force. And these are the forces because these 3 members were cut here, right? So I have shown them as a force. Am I clear? Right? And also you should not forget the external forces, whether it is a reaction or it is a applied forces. So everything remains as it is. The only thing is when you cut a section, your members become the forces. And without forgetting, assume that all the members or all the forces which are converted are working in tension. So here you can see when I cut member BC with section 11, it becomes force BC. When I cut member AC, it becomes force AC. And when I cut member AE, it becomes force AE. All members you will see here are moving outward. So that means all are them working in tension. So what happens on the counterpart? The counterpart, that is right hand side part, which I have shown here. The right part is also experiencing the same thing. The same member. The only difference is I have not mentioned the member forces names, but they are the same forces. Like I can say that this is force CB, this is force CA, and this is for EA. Okay, so all of them are still working in tension. Here on the other side, I have highlighted name of the forces on left hand side because, as you have guessed, we are going to work on left hand side. You, by your choice, can work on right hand side also. There is no problem at all. But once you work on the right hand side, forget about left hand side. Let the world of the left hand side do whatever they want. We are not concerned. Similarly, right now, if I want to work on a left hand side, I will completely forget what is existing in the right hand side. Since it was a little light weighted, so I have selected left part. You, if you wish, you can go for a right hand side part also. So I hope it is again very simple to understand and clear. So let me repeat once again everything for your clarity. We selected here the section 1.1, the section line which divided the truss in two parts, left hand side and right hand side, as shown in this right hand side figure. And we have replaced all those forces, all those members which are being cut in a form of a force. Remember, when you cut a member, then only you have to take it as a force. Don't show all the members as forces. The member which are being cut are only shown as the forces. So here you can see member AB. This is member AB. We have not touched it because it is not being cut by our section. Here from our section, only 3 members are being cut, and only those members we have replaced as the force without changing their geometry, their location, nothing, anything. We just simply representing a member as a force. So I think now we all are clear. One thing I have noticed that there are nearly 40 students in this group, and right now I can see only 25 have entered the chat box, the details. Later on, probably I understand you are focusing on content. So later on or at the end of the class, I will allow you to enter your details in the chat box for last 2-3 minutes. So don't worry, you can enter your detail at that time also. So let's come back to this discussion. I'm sure that most of us are clear and there is no doubt about it. It is very, very simple to understand that I have cut the section 1.1 and divided truss in two parts. Let us focus on left hand side part. Now you would definitely understand what is the next step. The next step is very simple. Apply sigma V, sigma H, sigma M on this part. That's all. The left hand side part, right? Because we are interested to use left hand side part. That's why. Otherwise, you can use right hand side part also and apply sigma V, sigma H, sigma M on this part also. Okay. Let's see what is the next one. Okay, now divide the truss in two parts, consider the equilibrium of any one side and apply basic equilibrium conditions. Let us consider left hand side part. So left hand side is ready with us. We have renamed all the forces and you can see here, since we have one inclined force, we have divided this inclined force into two components. Right. So naturally the vertical line or vertical arrow represents FAC sine theta, and the blue line, horizontal line, represents FAC cos theta. Theta you can obtain from the geometry, which is already calculated, that is 45 degree, so should not be a problem. So let's apply sigma V equals to 0 first. And how many vertical forces we have in this left hand side system? One vertical force is VA, that is 35 kilonewton, and second vertical force is FAC sine theta. So as usual, you will see that we have simply used this equation. Both are moving upwards, so we have taken both of them as positive. So here you can easily find value of FAC using the regular equation now. So you will see that we have find FAC as minus 50 kilonewton in compression. And that is what is the desired answer. Since we have done this first time, it took more than 8-9 minutes to explain you. But once you practice it, it won't take more than 5 minutes to determine the forces in the desired members. Right. So with this, we have calculated our first answer within no time. As you can see how wonderful it is. And it is very simple also. Just we have divided the truss, we have replaced the members by forces, we simplified the inclined forces in components, and then we start using sigma V, sigma H, sigma M. Why I have only shown sigma V equals to 0 here? Because our purpose is solved. So there is no need to apply sigma H and sigma M anymore. Because once your purpose is solved, you don't need to go for any single calculation. Just you simplify that your force was required in member FAC. So we have got FAC as minus 50 kilonewton, which is showing that the diagonal is in compression. And the same answer you can compare, which you earlier have calculated in the earlier section, that is FAC was in compression and the value was 50 only. So this is what is your first answer. Now one more member force which is required, that is CE, member CE. So now we need to select another section. Now please understand, this is the second part of this numerical. You have to select another fresh new section on a old truss or intact truss. Now how to do it? Let's see. Now I will go for another section. So this is section number 22 because we are interested in member CE. So CE member is a vertical member here, you can see, and I have used the section in such a way that it cuts the truss in two components. Upper one will be left hand side, below one will be right hand side, and you can see here these three members are being cut. And in these three members, we notice that CE is already included, and that is what is required also. So do not forget that you have to select the section in a way that it includes the member which is to be determined. So I am expecting that all of you are clear how to select section like this. Right? This is a fresh section. So now we will not remember that, oh yes, earlier we used the section 1.1 and we divided the truss in another way, and we have calculated ACF. We are not concerned. Now whatever is known, whatever is unknown, we are not at all concerned. Right now, our world is the new world with section 2.2. Okay. The only old knowledge that you should possess with you, that is the reaction values. That's all. And the geometry, of course, nothing else. Whatever has been calculated, we will not remember. AC is determined, but we don't know, like that, because we are now interested in CE. Okay. So let's go ahead and let's cut the truss in two components. Now you will see that we have cut the section here. We have utilized this section 2.2, and which has separated many members together. Like we have cut CD member first of all here. So you will see that I have shown CD member as a force, right? Now, second member which is being cut, that is the desired answer, that is CE. So I have shown CE member as a force, right? And similarly, last member which is being cut, that is member AE. So I have shown member AE as a force. So all these three forces are reflected in a reverse direction here on the counterpart. Counterpart is a right hand side bottom part, and where you can see that this becomes now force. So this is just a force. This member CE also becomes a force. So this is just a force. And also this is also become a force. So this is a force only. So when you match this left hand side and right hand side together, it converts into the original truss. But when you separate them by cutting it, they are to be represented as the forces. All forces, you will notice that they are moving outward. So all are working in tension. If we receive final answer in negative, that means it is in compression. That's all. But you don't need to change any sign or any of the values, earlier calculated forces, nothing. Just start a new section and your new word starts. Right. So it is as simple as that. Okay. Now, VA is already there, calculated on left hand side. Again, we'll focus on left hand side only. However, there is no rule. Let me tell you another beautiful way of using method of section. In previous section, we have focused on left hand side. Now, in this, if you are interested in right hand side, you can use right hand side also. Should not be a problem. Only thing is we have to focus on our desired force value. That is this one. So if I'm using right hand side, you can apply sigma V, sigma H, sigma M here also, or you can use or continue to use this side also. But for a consistency, this time also I'm considering the left hand side portion for equilibrium. And then let's see how to modify it. All right, so on the left hand side, I'm going to consider the equilibrium equations. What are the equilibrium equations available? Sigma V equals to 0. So tell me how many vertical forces are acting on left hand side part. So first is the reaction, that is 35. Then we have FCE, which is working downward. And of course, we have to divide this FCD in two components. So let me use a line here. This is vertical FCD sine theta, and this would be the FCD cos theta. So this 1, 2, and 3 forces are in vertical direction. So this is 1, 2, and 3. Both these are going down, so they are negative, and this 35 is going up, so it is positive. Angles we already know, so there is no need to consider anything else, right? So it is sine 45 because this angle is 45. That's all. Okay. Now here again we have to go for sigma H equals to 0. So how many horizontal forces now are in system? One is here, that is FA, right? So that is what is moving towards positive way. So it is positive. FCD horizontal component. So that is FCD horizontal component cos theta. And this is externally applied force that is moving negative. So it is minus 20. This is what we have used here. Now you will see that in each equation, sigma V, sigma H, earlier it was fortunate enough that we didn't want to, or we didn't need to go for any other additional equations. But here you will see that the forces are two unknowns in one equation, so which are difficult to solve. So let's go to the third option, that is taking moment of all the forces about a specific point, such that it solves our these two equations. Now you can observe before you go for this step, you observe this and this. So somehow if we get the value of AE, it will be easy for us to find CD. And once we have CD, you can further use it in another equation and you will find your dream force, that is FCE. This is what which is wanted, right? This is a problem statement. So now let's see how you should or where you should take moment such that your unknown force Fe can be determined. So if I take moment about this point C, I'm talking about only left hand side, right? We have nothing to do with right hand side. So don't look at to that also. Don't worry about it also. Let it be whatever. So on the left hand side, now we have 3 points, point C, point B, and point A. So if I take moment about point A, I will have to see moments of unknown forces, which will not solve the purpose, because I have 3 unknown forces, 1, 2, and 3 here. Of course, I can take their moments, but it will not solve my purpose, right? So if I take moment about point B, again, I have some unknown forces like FCE and FCD sign component. So these two are still unknown, right? So it will add one more unknown, that is FAE about point B. So if I want to avoid all these unknown forces, and though even I want to take moments, I will take moment about point C. Okay, that is what is my basic logic says to me. So these type of exercise you have to carry out when you are taking about moment about a point. So if I take moment about point C, these all are unknowns, right, which are gone away because I cannot take moment of all these forces. So my main trouble, main hurdle is removed. Now I have only 2 forces to handle. One is this, which is unknown, that is FAE, and this reaction, that is VA. So you know the distance of VA force as well as FAE force from point C. So by geometry, if you recall, 35 into 3. So this distance is 3 meter, right? This distance is 3 meter. If you check and go back to the geometry, and FAE is also located at vertical distance of 3 meters, right? So as usual, let me remove all the marks so for a clear picture. So now we can see that VA value is at 3 meter distance. If I extend this geometrical data, this is 3 meter, right? So this is the force and this is the distance. This is our reference point, which can be shown here also. It is as good as this, right? So this is the distance and this is the force. It will create clockwise moment. So 35 into 3. And similarly, FE, this is a horizontal force and it is located at 3 meter distance because this height is 3 meter, right? And we are taking moment about point C. So it will give you anti-clockwise moment of FA into 3. So when you take this moment of all the forces about point C, it will give you value of FAE, and that is tension. And you will compare this, you can compare this answer with your earlier calculated answer by method of joints, and it is same. One thing you should remember, whichever method you should use, like method of section, method of joints, whatever you use, the final answers will be never be changing, or they should never be changing. That is a cross check. So confirm your answers by using both methods together on a same truss. That is a best idea to practice on both the sectional and joint methods. So here, as you can see, we have calculated FAE. Now use this information in equation B. So we will bring that value of 35 here and get the value of CD. So 35 plus FCD cos 45 is 0.707 minus 20. This is minus 20. So we get FCD equals to minus 21.22 kilonewton compression. So this force is also determined. And now this information we will be using in finally in equation A. So let us put the values. 35 is 35. FCE is FCE. FCD is minus 21.22. Don't forget to actually use the actual numerical value with the numerical sign. So it is minus 21.22 into sine 45, that is 0.707. So that gives us a kind of solution like FCE is the final answer, that is 50 kilonewton, and that is 2 in the tension. So you can see that finally we receive our both the forces CE as well as AC. Right. So we can say that both the forces are calculated. You will notice that we have determined both the answers in terms of member forces for the members AC and CE using method of section, and that is too without analyzing entire truss. This is very important. We didn't go to joint D, joint E, joint C, B, A, anything. We just focused on the desired members only. And that is the best part of this method. And that is why this method is being liked by all the engineers for manual calculation in the critical member sections. It is not always used because ultimately you have to calculate member forces in all forces. But for manual calculation, in selected members, definitely in examination also, definitely this method is more convenient and faster. So you have to, whenever you come across to your examination question, read the question carefully. If it is said that, if it is asked that, find the member forces on X and Y member directly in the truss, without any delay, you should start using method of section. But if the instruction is like this, that given below is a truss example, calculate the member forces in all forces or all members, then I would advise you to use method of joints, because without which you will not be in a position to calculate all the member forces. Method of section is dedicated for selected member forces, while method of section provides solution for entire truss. So read the instruction carefully and then you obtain the answers. So these answers are comparable to the answers of the method of joints completed earlier. So now you can compare these answers also, and you will see that both answers are same, including nature of the forces, including tension and compression. Right? So please note following while using the method of sections. Anyhow, I'm going to distribute this material to you also, so you don't need to write anything as such, but let's go through it quickly. For a given truss, as many sections are needed can be selected, but they need to be applied one at a time and divide the truss by any one section at a time. This is very important. So as you have noticed earlier, we went for section 1.1. At that time, we didn't think even that what will happen if we select this section or not. So there is no confusion about it now. So select a section at a time, and in second option, when we selected this, we forget that what we did earlier, right? So this is what is must remembered by everybody. The second point is the section line may be straight or curved also. That doesn't matter. So there is no hard and fast rule that this what I'm saying is this line should be a linear line. You can cut it like this also, no problem. So there is no concern with this shape of this line. The only thing is its function is to cut the desired members only. So let us say instead of this straight line, I can use line like this also. Should not be a problem, right? So that is the second rule or second point. The section line must cut the member under the consideration at least. So out of 3 members, 1 member should be the member in which we want to find the force. This is a basic need, without which there is no meaning of using method of section. Next is no more than 3 members should cut. You know already that, and what is the reason that you also know that we have limited equilibrium conditions in planar truss analysis, that is 3 only, sigma v, sigma h and sigma m. So only 3 conditions are there. That's why our section should not cut more than 3 members. Next is the equilibrium can be considered for left hand side or right hand side parts. Now it will be interesting for you to exercise this. See, after this class, whenever today you are free, try analyzing the method of section and try to consider right hand side. Here in this case, I have solved the problem using left hand side. You consider right hand side and try to solve the problem, right? That will give you a very good learning experience also. The equilibrium can be, yes, that is done on left hand side or right hand side, whatever you are free at your end. And even though once you have used left hand side, in other section you can use right hand side. There is no rule at all, hard and fast rule. So it is very, very flexible method in other ways, right? And finally, if in a first section the analysis is done considering the left hand side, the same thing is written of the truss statement. In a second statement, right hand side part can be considered, no issues. Okay, so there is no rule at all. So this will give you a kind or plenty amount of flexibility in your calculations. So it's a very powerful method together. So I'm sure that most of us, like up to today, I can say up to 90% of the learners, those are in this group, must have get their clarity, very much clarity on how to use method of section. Quickly, let me bring you to the force table. This is a very old table that we have earlier prepared. You can compare this table with the earlier table. This is the same table, right? So answer should be same. So this was the pictorial view, right? So now let me quickly bring to this problem. However, in the handout that you are going to get, I have tried to give you the solution of this problem also. Let us read the question. Determine the member forces in member BG and GF. Where is BG? BG is here. And where is GF? GF is here. So you can imagine that if you start using method of joints, it will take a lot of time and it will be more focused on, carefully calculating everything and all this. But do one thing, do not start hating the method of joints. After learning the method of section, don't start hating the method of joint, because it has its own beauty, it has its own capacity, and it has its own level of easiness. If you recall, we didn't use any sigma m equals to 0 in that case, right? So method of joint is, on one hand, it is easy, but it requires more time. On the other hand, method of section is faster, but has a limitation that you can only find the limited number of member forces, right? So I have shown the solution of this problem. When you want to convert, when you want to calculate the reactions, you can use it as a simple beam, as I have shown on the right hand side. So I have shown the right hand side view for simplified view of this truss. You can simplify it because our first step is to find the reactions. So to find the reactions, you can go for this geometry and you can simplify the problem. You will be able to calculate the reactions within no time. This time we don't have any horizontal force, so a vertical reaction at point E will not be there at all. So only 2 reactions are needed. Okay. Along with that, you should keep calculating the important geometrical values, like in case of theta. Like here, we will need a theta value, right? Here we'll also need a theta value. So anywhere you will be requiring theta value here also. So based on that, I have already calculated theta values for you. Here you can see, right? So likewise, you can find the necessary values. Okay. All the geometrical dimensions are shared with you, given to you. So you can easily work upon this. Once your reactions are calculated, you can select, because our first aim is to find member force in BG member, right? BG member. So see, I have selected a very simple and straightforward uh, section over here. 1, 2, and 3 members are being cut. This is member 1, this is member 2, and this is member 3. So I have cut this truss like this, and you will see that I have replaced all the members with the force in the same geometry. You should not change this geometry in that case. Just simply cut it. That's all. So this is left hand side, this is right hand side. As usual, I'll be considering left hand side for solution of BG force, right? Okay. So similarly, I have calculated the reactions. Do not forget to bring with you the externally applied forces, whatever forces are there. On this side, we have 2 forces. On this side, we have 1 force. You can see this location, right? You can compare it. So this is nothing but this one only. So when you club them together, it will become the original truss like this. So I have selected my first section, and then I have solved it. Now this time it's little challenging. Sigma v equals to 0. So on this part, we have to see that how many vertical forces are there. These 2 forces are inclined, so we will simplify them in 2 components. Like this is vertical. Assume that this line is vertical and this is horizontal, though the drawing is not perfect. So how many total vertical forces we have? This is 1, this is 2, this is 3, and this is 4. So I have shown all the 4 forces here. This is 212.5 moving upward, it is positive. 100 is moving downward, so it is negative. FBG sine theta. So this is FBG sine theta moving downward. You can see here, so it is negative. And this is moving upward, FBC sine theta, so it is positive, right? So this gives me my first equation. Now sigma h equals to 0. How many horizontal forces we have? 1, 2, and 3. So we have 3 forces, FHG, so that is directly I have written, which is originally positive. FBG cos theta. So FBG cos theta is also moving positive, so it is positively written. And FBC cos theta, so that is also moving in positive direction. Do take care of the inclinations. Not all the inclinations are same, because this member BG is making an angle here, and this FBC is making an angle with this horizontal line. So these 2 angles are different, so that you have to calculate. I have already earlier calculated it. You can refer back to the earlier slide also, right? Now this will not solve the purpose, as you know, because there are many unknowns, full of unknowns are there. So take a moment. So sigma m equals to 0 on left hand side. Now let's decide where you should ideally take a moment. So here you can see that if I take moment at point A, it will bring lot of unknown forces in my equation, which I don't want. If I take moment at H, and that means at this point, it will again bring unknown forces in my calculations, which is not possible. So what I will do is definitely I will take moment on point B. So this is the point B I'm highlighting right now, and I will take moment of all the forces, possible forces about point B. So how many forces of which I can take moment? This is FHG, which is horizontal force. So it is here, right? I can take moment. This is a distance, this is a force. It will give me anti-clockwise moment about point B. And this is my vertical reaction. So that will allow me to take moment about point B at a distance of 5 meters. So that is what I have exactly done here. 212.5, that is reaction into 5 minus FHG into 3. So FHG is here. This is distance given to you. Here you can notice it is 3 meter, right? So that you can utilize here and get your answer in terms of FHG. But FHG will again not solve our direct purpose of calculating value of FBG. So in this case, we have to use result in equation B, and that will simplify this portion, that will convert this FHG in numerical data, and then you have to use method of elimination to solve these two equations parallelly. So I have shown all these things here, all the calculations are shown over here, and by method of elimination, you can eliminate whatever is the desired value. Here in this case, I have eliminated force BG, right? And I have received this as result of BC, and value of BC, you can put any of the equation and you will finally get your desired answer of BG. So as you can see, in method of section, no doubt it is very much direct, but it requires a lot of efforts when, especially when it comes to the taking of moment and using them and solving the problems. But otherwise, it is a very simple method to understand. So friends, I think I should stop here, and I have only solved one problem, that is for HG. You can practice with GF also on your own. Try to cut. Let me give you a tip. You can take a section like this, which cuts the truss into components like this. So this part is left, this part is right. And then you just try to see that is it possible to solve or not. I'm sure you'll be able to solve it. Right, so I'm removing all the marks over here. So this is a very similar image. The handout I like to share with all of you. So till then, I think you should practice more, and in case if you have any concerns, you can share here. I will go through it later on. Right now, I can see there are 2 or 3 questions in chat box. So definitely I will refer to them and come back to you in the email also, right, to the concerned person. Otherwise, I will share this with you. I'm sure that it is very easy to understand. So in the next session, we'll see that whether we do need to go for any other practice work of the method of section or method of joints. Otherwise, we'll carry on with an entirely new topic, right? So truss analysis consists of 2 methods, method of section, method of joints. We have taken examples, solved them, practiced it. Now it's up to you that how you practice it. Okay, so thank you all for joining this session, and take care in this pandemic conditions, and whatever handouts I'll be sharing with you, you should focus on that. Okay, so thank you all for joining. I'm stopping the session here. Have a good time. And those who have missed their entries as decided, I will keep this session open for next 3 minutes. Please make sure that every one of you have entered their details in the chat box. I'm not stopping, I'm not ending the session. I'm keeping it open. So please enter your details and then leave the class. Okay, thank you all. So it is open. I'm just muting myself for next 3 minutes, and then I will end the session.